All right, so in today's lesson, we're going to review the chemistry that you guys need to know to understand how the macromolecules are put together. So a lot of this is going to be a review of physical science that y'all had last year. So let me get everything on there. So here we go. So you should recall that the atom is the basic unit of matter, and atoms are made up out of protons, neutrons, and electrons. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge. Recall that the protons and neutrons are located in the nucleus of an atom and have equal mass. Electrons are located outside the nucleus and are much smaller than protons and neutrons. Okay, so here's a picture of an atom. This is a helium atom. I'm going to draw in the nucleus. There we go. Boop. Okay, we got the 2 protons in the nucleus, 2 neutrons in the nucleus, and then the 2 electrons in the outer shells. Okay, so remember that an element is made up of only one type of atom. The atomic number tells you the number of protons and the number of electrons only, remember, in an atom, because by definition an atom has to be electrically neutral, so the number of positive protons has to equal the number of negative electrons. Okay, so the sum of protons and neutrons is called the mass number. To find the number of neutrons, you're going to subtract the atomic number from the mass number, and you can find the atomic number and the mass numbers on the periodic table. So for example, lithium has an atomic number of 3 and a mass number of 7. The number of neutrons will be equal to 7 minus 3, which is 4. So on average, a lithium atom has 4 neutrons. Okay. Remember, isotopes are atoms of the same element that have different number of neutrons. So it is possible that atoms of the same element have different number of neutrons. So the number of protons has to be the same. Once you change the number of protons, you've changed the type of atom, and so you've changed the type of element. The atomic number has to be the same because the number of protons doesn't change. Okay. The number of neutrons can be different because a neutron has no charge. If you add a neutron or lose a neutron, it doesn't affect the identity of the atom or element. Okay? An example that you'll see a lot is carbon-12 and carbon-14. Okay? Both carbon-12 and carbon-14 have 6 protons. All types of carbon have to have 6 protons. By definition, they have to have that. All right, what is different is the number of neutrons. So carbon-12 has 6 neutrons. So you do that by taking the mass number of 12 and subtracting the atomic number of 6. So these bold numbers tell you the mass number. Okay. Carbon-14 is going to have 8 neutrons. 14, the mass number, minus 6, the atomic number, gives you the 8 neutrons. Okay, so the number of neutrons can change within the same type of element. Okay, some isotopes have nuclei that are unstable and break down at a constant rate over time. Those are called radioactive. Most atoms are not radioactive. Some of them are. Okay, so here's a diagram showing you the different isotopes of carbon. Okay, notice that in these examples, they all have 6 electrons. They all have to have 6 protons. That's what makes them carbon, is their number of protons. And what is different is their number of neutrons. Carbon-12 has 6 neutrons. Carbon-13 has 7. Carbon-14 has 8. Okay, so chemical compounds. A compound is a substance made of atoms of different elements bonded together. Atoms in a compound are held together by chemical bonds. Chemical bonds involve electrons, not protons, not neutrons, electrons that surround the nucleus. Specifically, it is the valence electrons that are involved in chemical bond formation. So if you have an atom, okay, let's say this is your nucleus, okay, and you've got some electrons here and some here, and maybe you've got 2 electrons out here. These electrons that I've underlined in purple, those are the outermost electrons, and these are the valence electrons. These outermost valence electrons are the electrons that are involved in chemical bonding. So valence electrons are your outermost electrons. Okay, so outermost electrons are valence electrons, and they are the ones that are involved in forming chemical bonds. Okay. An ionic bond is formed when one or more electrons are transferred from one atom to another. If an atom gains an electron, it will become negatively charged because an electron has a negative charge. So once an atom gains a negative charge, it will be indicated as an exponent. So this O2 negative tells you that this oxygen atom has gained 2 negative charges. If a neutral atom loses an electron, it becomes positively charged. So the sodium atom, Na1+, tells you that sodium has lost 1 electron and has 1 extra positive charge. So positive or negatively charged atoms are called ions. All right, covalent bonds. Covalent bonds are bonds that are formed when atoms share electrons. The structure that results when atoms are joined together is called a molecule. And a molecule is the smallest unit of most compounds. Okay, so here's an example. We're going to talk about water in depth in just a minute. So there's an example of a water molecule. Okay, when the atoms in a covalent bond share electrons, they don't always share equally. Okay, and because of unequal sharing, regions on the molecule can have positive or negative charges. Okay, the region of the molecule where electron spends more time is negatively charged, because remember, electrons are negatively charged. The region of the molecule where electrons spend less time is going to be positively charged because they're missing one of their negatives, just a little bit. Okay, so here we go into the properties of water. The first property is polarity. The oxygen end of a water molecule has a slightly negative charge, while the hydrogen end of a water molecule has a slightly positive charge. So a real simple sketch of a water molecule. Here's your oxygen, here's your O, here's your hydrogen. Okay, this oxygen atom is stronger in terms of being able to pull electrons than the hydrogen. So this oxygen has a slightly negative end, and these hydrogens have a slightly positive end. That's what we mean by polar. Okay, one side of the molecule has a positive side, the other is slightly negative. Okay, hydrogen bonds. Because of this partial positive and negative charges, water can attract to each other. So the attraction between the hydrogen atom of one water molecule and the oxygen atom on another water molecule is an example of a hydrogen bond. Okay, so if we look at this slide, okay, all of our oxygens are slightly negative, so I'm going to put a little negative here. Got all my oxygens. My hydrogens have a positive charge. I'm going to put a positive by all of my hydrogens. Okay, and as you recall, opposite charges attract. So this positive hydrogen is attracted to the negative oxygen. Positive hydrogen attracted to negative oxygen. Positive hydrogen attracted to negative oxygen. Positive hydrogen attracted to negative hydrogen. So all of these blue lines represent hydrogen bonds. Okay, oops, let's see what's going on here. Okay, here we go. Other properties of water is that it has a high specific heat, meaning that it is difficult to change the temperature of water. If you've ever been waiting for your mom to make you spaghetti for dinner and she has to boil the water, you know that can take a really long time. Those hydrogen bonds that we just talked about are really strong, and so it takes a long time to weaken those bonds and get the water to boil. So it's hard to change the temperature of water, either raise it or lower it. An attraction between molecules of the same substance is known as cohesion. This is what makes water molecules stick together. So cohesion is what enables like puddles to form. Okay? An attraction between molecules of different substances is known as adhesion. So adhesion allows water to stick to things besides other water molecules. So this is what enables, like water, when you have water on the outside of your glass in the summertime, when you get all that condensation and the outside of your glass gets all wet and leaves a ring on the table, and your mom gets a little mad because you left a ring on the table. All right, moving on to solutes and solvents. All right, so a mixture of two or more substances in which the molecules are evenly distributed is known as a solution. The substance that is dissolved is known as the solute. The substance that is doing the dissolvent and is usually present in the greatest quantity is the solvent. Water's polarity gives it the ability to dissolve both ionic compounds and other molecules, and so it is usually called the universal solvent. So if you're making like lemonade, right? So let's say you've got the lemon. That's not how you spell lemonade. Anyways, you've got the lemonade powder, right? And you've got water. You got to mix those two together to make the lemonade. The lemonade powder is what gets dissolved, so that's the solute. The water is what causes the powder to dissolve, so water is the solvent. All right. Acids, bases, and pH. Recall from physical science that the pH scale indicates the concentration of H positive ions in solution, and the range is from 0 to 14. Okay. An acid is any compound that forms H positive ions in solutions. Acidic, which is just a derivation of the word acid, acidic solutions contain higher amounts of H positive ions than pure water. Acids will have a pH value below 7. A base is any compound that produces hydroxide. This OH negative is called hydroxide ions in solution. So basic, sometimes called alkaline solutions, contain lower amounts of H positive ions than pure water. They will have a pH value above 7. The pH of most fluids in the human body must be kept between 6.5 and 7.5. So that's a pretty narrow pH range. Okay. One of the ways that the human body controls pH is through dissolved compounds called buffers. So a buffer is a weak acid or base that can react with strong acids or bases to prevent sudden changes in pH. Like in an acid tablet, it's a type of buffer. If your stomach acid gets a little too out of control, you take a Tums and it calms down that stomach acid for you. Okay, so here we have our pH scale. Okay, starting at the bases, you'll notice that a lot of the bases are used for cleaning various things. Oven cleaner, bleach, ammonia, stuff is so stinky, soap, seawater, slightly basic, human blood. Notice human blood is a little basic. Pure water is neutral with a pH of 7. So most of our water is not pure water. We've got different ions in there. Like I know they put fluoride in it. So if you don't make it to the dentist, at least you've got something to help your teeth. Normal rainfall is just barely acidic. Lots of fruits. Tend to be acidic. Notice stomach acid is very acidic. And yeah, there we go, some common acids and bases. So a lot of this hopefully was a review of stuff that you were supposed to learn in physical science. If not, well, don't worry about it. As you know, we will work with these ideas in class over the next couple days. So I will see you later.